Dear students, in the present session, we will discuss how to compare two population standard deviations using independent samples. In the previous class, we have discussed how to make inference about one population standard deviation. The test statistics used for the purpose was chi-square distribution, n minus 1 into a square by sigma square with the n minus 1 degrees of freedom. Now we consider inferences about two population standard deviations or two population variances using independent samples. We introduce both the hypothesis testing and also construction of confidence intervals for two population standard deviations, just as we did in the case of one population standard deviation or one population variance as in the previous class. To make inferences about one population standard deviation, the test statistics was chi-square distribution, and we have discussed in detail the properties of chi-square distribution, etc. But to make inferences about two population variances or two population standard deviations, we have to introduce another distribution known as the F distribution. Named after Fisher, named after Ronald Fisher, or in order of Ronald Fisher. So we use F distribution. So we have to study the characteristics of F distribution. So remember this. We have used the Z distribution and T distribution for testing hypothesis about one population mean, one population proportion, comparison of two population means, comparison of two population proportions. To test the significance of one standard deviation, chi-square was used. To compare two population standard deviations, the test statistics is F. And in the basic inferential statistics procedures, the test statistics we use are Z, T, chi-square and F. These are the distributions used for hypothesis testing at an introductory level. Now let me formally define what is an F distribution. A variable is said to have an F distribution if its distribution has the shape of a special type of right skewed curve called an F curve. A variable is said to have F distribution if its distribution has the shape of a special type of right skewed curve called the F curve. Now, there are infinitely many F distributions, and we identify an F distribution by stating its degrees of freedom. There are infinitely many F distributions, And we identify an F distribution by stating its degrees of freedom, just as in the case of T distribution and also chi-square distribution. As we have seen, there is only one Z distribution, but an infinitely many T distributions depending on degrees of freedom, infinitely many chi-square distributions depending on its degrees of freedom. Actually, F distribution has two numbers of degrees of freedom. F distribution has two numbers of degrees of freedom instead of one. In a subsequent class, we will discuss the interrelationship between Z, T, chi-square and F, and we will show that the degrees of freedom of F is derived from the degrees of freedom of chi-square. Anyway, F distribution has two degrees of freedom, two separate numbers of degrees of freedom. The first is called the numerator degrees of freedom, and the second number of degrees of freedom is called denominator degrees of freedom. So F distribution has two numbers of degrees of freedom. This is F distribution, this is F of F distribution, and the S distribution has this shape, and as I said earlier, there are infinitely many F distributions depending on numerator and denominator degrees of freedom, and for this degrees of freedom is 10 and 2. For this degrees of freedom is 9 and 50. So F distribution has a numerator degree of freedom and a denominator degree of freedom. The first number is the numerator degree of freedom. The second number is the denominator degree of freedom. Now let me say what are the properties of F distribution. As in the case of Z, T, chi-square, etc., total area under the F curve is 1. Total area under F curve is 1. Second is F curve starts at 0 and extends infinitely towards the right, approximating but never touching horizontal axis. It starts at 0 in the horizontal axis, extends infinitely towards the right, approaching but never touching the horizontal axis. Second property. The third property is it is right skewed. Like a chi-square distribution, F distribution is also right skewed. But as you can see, as in the case of chi-square distribution, as the degrees of freedom increases, it approximates a normal distribution. It approximates a normal distribution. So, area under F curve is 1, starts at origin, extends infinitely towards the right, approaching but never touching the horizontal x-axis. It is right skewed like the chi-square distribution. Now, the probabilities or the percentages for a variable having F distribution equals area under the F curve. If a variable has F distribution, you can calculate the percentages or the probability of the variable as area under the F curve. Area under the F curve. Now, to perform a hypothesis test and also to construct the confidence intervals for comparing two population standard deviations. We need to know how to find out the F value that corresponds to a specific area under the F curve. Remember this, F distribution is used for comparing two variances or comparing two standard deviations. F distribution is also used for constructing confidence intervals for two standard deviations or two variances. So, in order to use F distribution for hypothesis testing and also for constructing confidence intervals, we must know how to find out area under the F curve, just as area under Z, under T, under chi-square required for hypothesis testing and also for constructing confidence intervals. Now the symbol F alpha, the symbol F alpha the symbol say F alpha, the symbol F alpha is used to denote F value having an area alpha to its right. Suppose that alpha is equal to 0.05. Then F alpha is the value of F having an area 0.05 to its right. So for example, if F alpha is 10, we will say that only 5% of the area under F curve lie to the right of 10. So F alpha shows the F value having an area alpha to its right. These probabilities are given, calculated and given in tabular form and available in all the textbooks of statistics, or you can calculate the areas by using a software. Now in the context of F distribution, a property which we use for finding the area under F distribution is the reciprocal property. Reciprocal property of F distribution. A property which is used to calculate area under F curve is the reciprocal property of F curve. Let me give a formal definition to what is meant by this reciprocal property. Now, for an F curve with the degrees of freedom V1 and V2, for an F curve with the degrees of freedom equal to V1 and V2, F value having alpha to its right, F value having alpha to its left equals the reciprocal of alpha value having area alpha to its right for an F curve with degrees of freedom V2, V1. That is the reciprocal property of F curve. For an F curve with the degrees of freedom V1 and V2, F value having alpha to its left equals reciprocal of F value having area alpha to its right for an F curve with the degrees of freedom V2, V1. Let me explain this point with the examples. Let us assume that alpha is equal to 0.05 or 5%. 5%. Now, consider f with the degrees of freedom equal to 60 and 8. Now, f 60 and 8 from the table, the f value is 2.1. 10. Alpha is 0.05. That means 95% of f for degrees of freedom 60 and 8 is from 0 to 2.10. Now, f for 60 and 8 for alpha 0.05 is 2.10. Now, what is the reciprocal? To the left, it is, that is 0.05 to the left is 1 by 2.10. 1 by 2.10, that is equal to 0.48. That is, for degrees of freedom 60 and 8, only 5% of the area is between 0 and 48. That is the reciprocal of 2.10. Consider another case, f 9 and 8. f 9 and 8. In this case, 95% of f is between 0 and 4.36. Only 5% is here, 0 and 4.36. So to the left it is 1 by 4.306 equal to, that is 0.05 is equal to 0.24. So this is 95%. This is 95%. Other values can be calculated like this. This is known as the reciprocal property of f distribution. One is, that is 5% to the right is equal to 1 by that 5% to the left. So this f distribution is used to compare the variances or the standard deviations of two independently distributed populations.